My name is Edison Miyawaki. I am a neurologist specializing in movement disorders at Brigham and Women's Hospital and Harvard Medical School in the United States. An AI-generated voice is reading a script that I wrote so that we can translate the next 20 minutes into languages other than English. In this talk, we will examine video segments of abnormal gaits to derive lessons that might organize an approach to the study of gait. The diseases which I have chosen to illustrate are uncommon, and I borrow recordings from publications that are cited in each instance. The gait seen here is considered characteristic or even pathognomonic of a rare condition, but what if it simply looks strange or incomprehensible to you? A useful approach is, first, to describe what you see without use of medical terminology that may be inaccurate. For example, to use the word festination, with its connotation of Parkinsonism, is not quite correct. On the other hand, to say that he looks as if made of rubber is better because it is more helpfully descriptive. As a next step in your thought process, you might ask, is the finding part of a syndrome? The elementary neurological examination in cases of the rubber person gait often reveals proximal weakness in the limbs, typically mild, and a peripheral neuropathy, often with areflexia. Elevations in creatine phosphokinase can be striking. The hallmark blood finding is the acanthocyte, seen in the electron micrograph to the right, but a search for acanthocytes is not routine in lab workups and requires expertise in methodology. There are other associations in neuroacanthocytosis syndromes, which comprise no less than 4 distinct movement disorders. Our emphasis in this video is on gait. We have already encountered 2 lessons in this talk. The first is to describe what you see with a minimum of medical words, if it is possible to do so. A second lesson can be stated simply: if there is an abnormality of gait, think for a moment about the possibility of a neurological syndrome comprised of perhaps many other pertinent positives. Neurologists learn early in their training that gait often summarizes the neurological examination. But gait is only a portion of a phenotype, and a gait disorder may manifest at a different time than other aspects of a syndrome. We continue with another case of neuroacanthocytosis to illustrate how phenotype in the disease is not restricted to a gait disturbance. This video illustrates tongue protrusion as the woman attempts to eat a biscuit. In so-called chorea neuroacanthocytosis, a problem eating due to tongue protrusion is characteristic, as is the rubber person gait, although the latter may develop later in time. By syndromal thinking, I refer to a holistic approach that increasingly in contemporary diagnostics leads to a role for targeted or whole genomic study. We will return to gene associations at the end of this talk. A next case comes from an extraordinary archive of movies made by Arthur van Gehoesten, a Belgian physician who lived in the late 19th century. I'll let you watch the film for a few moments without commentary. One might say that there is nothing clearly wrong with the woman's gait for a few seconds after she bows to the camera, but a paroxysm occurs, then she rights herself momentarily with her feet close together, then she falls to the ground, but is able to get herself upright again, then she resumes walking. Is it the case that a gait abnormality will always be the same during any walk, at any time of day, without episodic worsening or any other variation? Are her arm and hand movements quite normal during the entire video? She clasps her hands most of the time, so perhaps it is difficult to conclude anything about the hands and arms. The more you look, the more questions you might entertain, including the possibility of a non-physiological problem. Consider this next gait in contrast to the last. Again, I'll let a few seconds pass without words. She is 27 years old and walking has been a problem over the preceding year. Dating to childhood, she had speech and language problems requiring special education. She does not walk straight down the hallway. Her right arm is flexed most of the time. She kicks her left leg as she begins forward movement. She does better walking backwards, as has been described in dystonic gaits. To define my term, a dystonia is an abnormal co-contraction of muscles that results in a fixed posture, like her flexed right arm. She can run straight ahead, but the arm is still flexed. Stress, excitement, and even a passing illness worsen her dystonia. According to her loved ones, she has episodes of thrashing in bed when she is clearly asleep or when drowsy. We can state a third lesson in light of the last 2 videos. Variability during a single examination or during a 24-hour day does not equal a functional problem. In fact, variability can be a clue to a correct diagnosis, whether presumably non-physiological as in the last video or physiological in this one. The overall syndrome that this woman illustrates, including the development of a gait disturbance years into its natural history, is consistent with her diagnosis of an ADCY5-related movement disorder confirmed by genetic testing. I will provide details about this rare disease later. A fourth lesson has to do with something that repeats itself in the course of walking. For example, in a normal gait, arm swing repeats itself in relationship to steps taken. What do we see in this video? I chose it because at first I thought the movements were just bizarre. But bizarre is not a helpful adjective. He twirls around when he walks. He spins in a counterclockwise direction. A movement of the left arm, as if to brush back his hair, precedes his turns. As it happens, his gait abnormality developed after a left subcortical infarct. Consider a description that I found in a paper from the early 1990s related to what is called stereotypy. The authors describe movements carried out in a uniform way, often for long periods of time, at the expense of other motor activities. Specialists talk about the purposelessness of a movement that gets in the way of other motor activities, as in the stereotyped twirling we have just seen. But perhaps repetitive aspects of a gait may not interfere at all with the task of walking. In this video, there are features we can try to itemize. Her arms are held away from the body. She stutter steps throughout the clip. Sometimes, briefly, she seems to catch her balance by leaning or twisting to either side. It takes at least 6 small steps for her to negotiate a 180-degree turn. As she walks towards the camera, she looks up to the ceiling. Do these features lack purpose? Do they get in the way of walking down the hall? Or are they, in fact, implicit in attempting to meet the request to walk in the first place? Like the majority of cases that we discuss in this talk, her syndrome has a genetic underpinning, specifically a Huntington disease genotype. But the point of the clip is to concentrate on phenomenology. It is often the case that a person may not be aware, and may even object to the observation that there is a change or abnormality in either posture or gait. Older neurologists like myself once used to examine what we called a stressed gait, for example, what happens when attempting to walk on the sides of one's feet. The idea was to elicit findings that otherwise would not be observed, such as a flexed wrist on one side or the other. We called such a finding a soft hemibody sign. Heel-to-toe walking is a stress testing method that is still routine, used most commonly to elicit ataxia, though it often reveals other findings, for example a lean or tilt only to one side. The point is that gait abnormalities can be subtle, as this video illustrates. The flexed right arm draws the attention, but is the gait in this young woman normal? I call your attention to her right foot compared to her left. Is there a sense that she almost walks on the outside of her right foot, or that the right foot turns slightly inward as she walks? In the original description of this syndrome, a dystonia with significant diurnal variation, clearly worse later in a day, typically involved flexion and inversion of one foot to start. Over roughly 5 years, the ipsilateral arm, then the contralateral leg, then contralateral arm became involved in sequence, such that eventually all the limbs were dystonic. Response to levodopa with improvement in posture and gait was a hallmark. Subsequent studies have implicated a number of enzymes involved in the synthesis of dopamine. Sometimes an abnormality of gait can be overlooked, or sometimes there can be a very obvious issue. In the next 2 videos I will provide examples of the obvious. This video of an 11-year-old illustrates an exaggerated instance of tiptoe walking, which goes by the name of a cock walk, like that of a rooster. I chose this video for 2 reasons. The first has to do with what happens when babies learn to walk in the first place. Toe walking, in which the heel does not touch the ground, is common and normal in learning to walk. But later development of toe walking generates a differential diagnosis. On the list is the so-called equinus deformity, a kind of fixed foot drop, seen in spastic hemiparesis after stroke. This case of a cock walk with involvement of both legs puts a movement specialist in mind of manganese toxicity, as occurs among welders or mine workers, in situations when a drug of abuse is contaminated with manganese, in cases of prolonged parenteral nutrition, and in chronic liver disease. The transmembrane manganese transporter is highly expressed in brain, especially in basal ganglia, and liver, and a recessively inherited mutation of the manganese transporter gene with associated high serum manganese is responsible for the phenotype seen here. Here is another extreme case and a different disease in a 64-year-old woman with a 3-year history of progressive gait difficulty. The first part of the video cannot be considered a gait. It is a crawl, but it is not slow. With a walker, she is able to make her way down the hallway rather quickly, but the legs are flexed and her entire trunk is pitched forward. In trying to get a sense from published reports of how such a problem starts, it is interesting to note that in one Australian family, a number of relatives were thought, at first, to have a cock-walk gait, but the appearance in this video and in other cases has put people in mind of riding a hobby horse or perhaps the forward posture and flexed legs of someone riding a real horse.
Now, what is the thing that bothers you most? Shaking. Now, what is the thing that bothers you most?
The gait in the last video developed late in the course of a syndrome characterized, above all, by a whisper that results from laryngeal dystonia. There is a story behind the previous video. The authors had followed two sisters, 2 years apart in age, 17 and 19, for over 3 decades. But identification of the causative gene happened only after many years, indeed after both sisters had been diagnosed with a different disease. Representative magnetic resonance findings are shown here. There is diffuse white matter change in the T2 image on the left. On the right, which is a T1 image, there is obvious thinning of the corpus callosum and of the cerebellum. Additional findings not indicated with arrows are basal ganglia and brainstem atrophy. This slide summarizes the preceding 2 videos and the radiographic images. In the case of this genetic dystonia, both autosomal dominant transmission and de novo mutations have been described. The responsible mutation, on chromosome 19, relates to the protein tubulin, a major component of microtubulin that is expressed throughout the brain, but particularly in cerebellum and white matter. We should now review several other of the genetically determined diseases that I have used in this video to illustrate aspects of the evaluation of gait. As I have done in this slide, I will identify a causal gene linkage, the mode or modes of inheritance, and the associated protein product. The intent of this talk is not to suggest that all gait abnormalities are genetically determined. The vast majority are not. But I do want to underscore how description of a gait phenotype can direct diagnostics. The rubber person gait and acanthocytosis are associated with chorea neuroacanthocytosis. The linkage is to chromosome 9 with autosomal recessive AR transmission. Acanthocytosis also has been observed in the X-linked McLeod syndrome, in Huntington disease-like or HDL type 2, and in one of several genetic syndromes with neurodegeneration and brain iron accumulation. The lesson of the rubber person is how important it is to describe descriptively and usefully. Of interest, chorea is actually not a word that immediately applies to the overall gestalt in the gait that we examined. Variability and distractibility are related, but not the same. The reason why we look for distractibility in a movement examination has to do with how commonly functional disease occurs. Estimates go as high as 20% of all movement evaluations. And functional phenomena often coexist with movement disorders with known physiological determinants. The reasons to show the case of the 27-year-old who kicks her leg to walk are several. First, variability differs from distractibility. Of note, she had dyskinesias, flailing movements in her case, in sleep and drowsiness despite the fact that most dyskinesias improve or disappear in sleep. Second, variation can occur in the course of life, in the course of a single day, and even in the time span of a clinical encounter. Third, in so far as many catecholamines, dopamine or DA in particular, are involved in stress response, it should not surprise us that disturbances in neurotransmission downstream from a receptor, like a striatal DA receptor, can result in paroxysmal worsening of a disorder in times of emotional or physiological stress, as occurs in ADCY5-associated dyskinesia. I showed the stutter stepping of this lady in a discussion of repetitive aspects in a gait. But a few words should be said about genetic variability in a Huntington phenotype. For example, HDL type 2 is typically seen in kindreds with African, including South African roots. Mode of transmission is autosomal dominant. The concept of a Huntington phenotype needs to widen when we think that the original linkage of Huntington disease to chromosome 4, with CAG trinucleotide repeat expansion and polyglutamine expansion in the associated protein product called huntingtin, is not the culprit abnormality in HDL type 2. Furthermore, a small percentage of patients with HDL type 2 will manifest acanthocytosis, as in the case of the rubber person gait. The young woman with the turned right foot and flexed right arm carries a diagnosis of a dopa-responsive dystonia with characteristic diurnal fluctuation. There are many genetic associations, all related to enzymes involved in the biosynthetic pathway for dopamine, or DA, in the lower right-hand corner of the diagram. I won't fully name all the enzymes and molecules, but some are worth specific mention. Guanosine triphosphate, or GTP, at the top of the diagram, it must be converted to tetrahydrobiopterin, or BH4, an essential cofactor for tyrosine hydroxylase, TH. TH is the rate-limiting enzyme for the whole pathway. The 8 genes encoding all the enzymatic conversions may undergo mutations, each associated with a movement disorder with diurnal variation. Many but not all of the associated phenotypes can be treated successfully with levodopa. The main point of studying this gait has to do with the fact that what we see may not be the whole story in one examination. 7 years before the video was taken, her first symptom, thought to be purely orthopedic in nature, was a limp of the left, not the right leg. There are gait disturbances whose cause, if just one cause is responsible, can be located low in the neuraxis. These include myopathies, musculoskeletal problems, and peripheral neuropathies. In the middle of the neuraxis, we can think of spinal, vestibular, and cerebellar disorders. High up, we are subcortical or cortical. Many gait disorders, especially those of the high and mixed varieties, are hard to describe both by patients and those who evaluate them. They can vary with circumstance, under stress, and even under examination, and with time. In conclusion, we can summarize our lessons from the study of gaits by way of showing you 5 mistakes and how to correct them.
It is Korea.
First mistake, first rule, describe descriptively.
It is only Korea. I mean, it's just Korea.
Second mistake, second rule, look around. Look for a syndrome.
It is always Korea.
Third mistake, third rule, things can change with time.
It does not repeat because it is Korea.
Fourth mistake, fourth rule, if something repeats, you have to notice that it does repeat.
The patient knows it is Korea.
Fifth mistake, fifth rule, the patient may not acknowledge a problem, especially when it is either subtle or variable or both, even to the examiner. Often, it is hard for people to articulate what problem they have, except by way of a generality such as feeling off balance. There is an addendum to the fifth rule, given the modern advent of genetic testing. A given phenotype, the one in front of the examiner, may only be a provocation to study the genome in what is becoming the increasingly complex task of accurate diagnosis. I hope that this brief video helps you in your evaluation of a simple walk. Thank you for your time and attention.